Is the slideshow visible
Yes, ma'am,
to
it's
you all?
visible. Yes, ma'am. Yes, ma'am.
Okay. I have taken class of Department of Printing and IT in the first sem before, and I have shown PDF, but I think the slideshow is better than PDF. That's why I'm um, teaching with slideshow this time, not with PDF. I think this will be helpful to you all. And this is better than PDF, I think. I will try to share this after finishing all my classes at the end of the lesson. But I think it will be better for you all to follow my all the classes. I will not take many classes. I will take 5 to 6 classes. I think not more than that. But I think if you all follow these classes thoroughly, then it will be helpful, as your syllabus is not like the honors classes. It is not in detail. Your syllabus is not in detail, so you don't have to you don't have to read all the proofs, or all the big proofs. You have to understand the small theorems which have small proofs, which are not very uneasy, very tough for you. So I think the theorems I have given in this slides will be enough for you. And if anyone wants to um, read more than that, then he or she can. But I think these are enough for you all. So just try to follow all my classes thoroughly, and try to understand the proofs I have given in the slides. That will be enough. How's your exams in the first sem? Your exams are over, I know. How was your exam? Maths paper. How was the maths paper? Is that easy? How was your exam? I just want to know. Was that easy or was that very tough? I'm questioning about maths first sem. I know the
Sir,
exams are over, but
ma'am, abstract algebra was a little bit tough, but all topics more average was average.
abstract was tough.
Little
I have
bit.
taken abstract. Okay. Why? Why that seemed tough to you?
Ma'am, 60% syllabus was not covered till exam
60% syllabus was not covered.
by the
Okay.
teachers.
So,
Ma'am,
who
not
took
60%. The entire algebra, entire calculus was not covered. Sir was not present. Preeti Kumar Roy, sir.
Preeti Kumar Roy? Oh, she is a madam, I think. She's a
No,
he's a
no,
sir.
ma'am, he's a sir.
He's a sir. Oh, I think I thought that he is a she would be a woman. Okay, so the syllabus was not covered.
Yes, ma'am, only the
Okay.
calculus portion was not covered, except the vector algebra and abstract algebra was covered.
And we had to put a lot of effort in covering the calculus syllabus by ourselves. That's why, ma'am, abstract got all left over.
Now listen that the classes are taken online, and offline classes are far more better than online classes. You all know that. So there are certain limits for us also to take your classes, and we can't, teach maths thoroughly through this online classes. I have not learned in my days from any online class, and I think offline classes are better for art subjects than maths, especially because maths can't be taught or learned through online, because you have to question the sirs and madams, and they have to give you answers, and that will be far more helpful than sharing the PDFs or the files. So I think we can't blame you, or you can't blame us, because I have taken classes of abstract algebra for same one. But you know what? I wanted to teach them thoroughly in details, but they were not quite attentive, and that's why I just, gave it up and shared that PDF of mine to help them. But I don't know how was their exams. That's why I'm just asking you all that how was your exams. You are also my students, and you know what, I'm very much concerned about that. So you have to make efforts yourself to do good in the exams. Okay, the exams are over, so you just can wait for the results. Let's hope for the best, and I think the results will be good. You have to just pass in these subjects. These are the past subjects. No, you have just to what score you have to secure. 50% to pass.
Yes, ma'am. They also
Ma'am,
contribute to
40%.
the SGPA, ma'am.
40% SGPA. Okay.
Yes, ma'am. It will contribute to our SGPA. That will matter
Okay,
for our
okay.
placements.
No, I have not seen the question because I'm not allowed to, because I'm just a research scholar, and sirs, the professors do the questions. So yeah, okay. Send me the question. Okay, one of you kindly send me the question in the group, or Joydeep can send me in my private WhatsApp.
Okay, ma'am.
Then I will check the first sem question. Okay. Okay, let's continue. Here I have given the recommended books. First, Application of Calculus by Sitangshu Bandyopadhyay and Sunil Kumar Maiti. Second, Calculus by T.M. Apostol. And third, for the sequence and series, this is Introduction to Real Analysis by S.K. Mappa. Application of Calculus by Sitangshu Bandyopadhyay and Sunil Kumar Maiti is very much useful, as there are many problems solved in this book. But the Calculus by T.M. Apostol is higher in level. So I think you can have the second book, Calculus by T.M. Apostol, just to read, to understand calculus well. But for exams or for solving problems, you have to follow the first book. And Introduction to Real Analysis by S.K. Mappa is absolutely necessary. This is for sequence and series. I think you have this books. It's S.K. Mappa, Introduction to Real Analysis. This is very helpful for real analysis, for all the chapters of real analysis, and for my chapters, sequence and series also. So first two books are for integral calculus, and the second book is and the third book, that is by S.K. Mappa, is for sequence and series. Okay. There are 4 theorems in integral calculus. You have to just read the statements. Proofs are not needed. That's why I have just given the statements. First, fundamental theorem of integral calculus. I think you all know already. If f from a closed interval ab to r be integrable on ab, and if possesses an antiderivative phi on ab, then integration a to b f is equal to phi b minus phi a. Okay, what is antiderivative? Do anyone know?
Ma'am, integration.
Antiderivative. What is antiderivatives? I have said that f possesses an antiderivative phi. So phi is an antiderivative of f. That is phi dash is equal to f. And that's why if we take integration of f from a to b, then phi this will result to phi b minus phi a. Okay, understood? A to B F is equal to phi B minus phi A. If possessing an antiderivative phi, that is phi dash X is equal to Fx over AB, or phi dash is equal to F. Antiderivative means just the opposite of derivative. You can call it integration. So if we take the integration of F, then the result will be in the form of phi. Next, first mean value theorem. If F from AB to R and G from AB to R be both integrable on AB, here R is the set of all reals and Gx has the same sign for all x belongs to AB, then there is a number mu such that integration A to B Fx Gx dx is equal to mu integration A to B Gx dx, where m less than is equal to mu less than is equal to m, where small m is equal to infimum of x belonging to AB Fx and capital M is equal to supremum over x belonging to AB of Fx. If further F is continuous on AB, then there exists xi belonging to AB such that A to B Fx Gx integration A to B Fx Gx dx is equal to f xi integration A to B Gx dx. Here G keeps the same sign for all x belongs to AB. That is either Gx greater than 0 or Gx less than 0. Gx has the same sign. Either it is negative or positive over AB, in closed interval AB. Then there is a number mu. So if F is continuous, then mu is replaced by f xi. That is mu is attended by F at certain number, that is xi belonging to AB. So mu is replaced by f xi if F is continuous on AB. This is the first mean value theorem. There are two forms of second mean value theorem. First, Bonnet's form and then Weierstrass's form. Second mean value theorem of Bonnet's form tells us that if F from AB to R and G from AB to R be both integrable on AB and F is monotone decreasing and non-negative on AB, then there exists xi belonging to AB such that A to B Fx Gx dx is equal to Fa A to xi Gx dx. What is monotone decreasing? Can you answer? What is monotone decreasing? F is monotone decreasing and non-negative. Non-negative means greater than is equal to 0. Monotone decreasing?
Strictly decreasing.
No, strictly increasing is a kind of monotone decrease. Strictly increasing is opposite of monotone decreasing. Monotone decreasing means
decreasing.
Monotone decreasing means if we take x and y from AB and x greater than y, then Fx less than is equal to Fy. That is, F decreases with the values increasing on AB. That is, if x greater than y, then Fx less than is equal to Fy. Okay, that is called monotone decreasing. And strictly decreasing means Fx less than Fy. Fx not is equal to Fy, but Fx less than Fy. That is strictly decreasing. And monotone decreasing means Fx less than is equal to Fy. Second mean value theorem, Weierstrass's form. If F from closed interval AB to R and G from closed interval AB to R be both integrable on AB and F is monotonic on AB, that is either F is monotonic decreasing or increasing, you can't have a certain condition. In the first form, we have told that F is monotone decreasing, but in the second form, F is monotonic. That is either F can be monotonic increasing or F can be monotonic decreasing. Then there exists also a xi belonging to AB such that A to B Fx Gx dx is equal to Fa A to xi Gx dx plus Fb xi to B Gx dx. You can easily see that in the first form, when F was monotonic decreasing, we have taken the first part, that is Fa A to xi Gx dx, and so the second part is for monotonic increasing. That's why F is monotonic increasing or decreasing. Then we can add the second part to the second form, and the first part is for the first form, that is Bonnet's form. So the first part, that is the Bonnet's form, is a generalization of the second form. So we can reach to the Bonus form from Weierstrass's form simply by taking if monotonic decreasing. The second form is for if is monotonic decreasing, either if is monotonic increasing, but in the first form, if is monotonic decreasing. So we can reach to the first form from the second form. These are all the theorems you have to study, and just the statements. You don't have to read the proofs because the proofs are quite tough for you. Next, there are certain reduction formulas. Reduction formulas are very important, and there are 5 or 6 reduction formulas I have given in the slides. Reduction formulas are very easy because they are just integration by parts and nothing more. Reduction formula, let mn be positive integers. First, let in is equal to sin nx dx. So we have to reduce it. We have to find the reduction formula for in, that is integration sin nx dx, where n is a positive integer. Then it is equal to integration sin n minus 1x sin x dx. And in the second step, you can see that we have integrated it by parts. That is, we have taken sin n minus 1x as a first function and sin x as the second function. So, integrating by parts, we have reached to the second line. You can see. Then, after that, we have just simplified the second line in the third line, that is minus sin n minus 1x cos x plus n minus 1 into sin n minus 2x cos square x, that is cos x into minus cos x results to cos square x. In the fourth line, we have replaced cos square x by 1 minus sin square x. In the fifth line, we have just simplified it, and in the last line, what we have got, that integration sin n minus 2x dx is equal to in minus 2, because we have taken in is equal to integration sin nx dx, and so replacing n by n minus 2, we get in minus 2 minus n minus 1 in, and then simplifying in, we get in is equal to minus sin n minus 1x cos x plus n minus 1 in by 2 by n. Okay. Next, let in is equal to cos nx. You will do it yourself, because similarly as above, we get in is equal to cos n minus 1x sin x plus n minus 1 in minus 2 by n. You have just to have to follow the similar steps as in 1 for solving 2. So you will do it yourself. Have you all understood the integrations? It's simple. Integrating by parts, then just simplifying and replacing cos square x by 1 minus sin square x, and then just there are in minus 2 and in, and simplifying the coefficients of in, we get last in. Is there any problem? Is it understood?
Yes, ma'am.
Okay. So if you have any question, just ask me, okay? Whenever you have any question, just ask me. I will try to answer. Because if your problems are not resolved, then you have to face problems after all the classes are over, and just okay. Next, let imn. There are two integers imn now, and imn is equal to integration of sin mx cos nx dx. In the second line, we have written cos n minus 1x sin mx cos x, and in the third line, we have integrated it by parts by considering cos n minus 1x as the first function and sin mx cos x as the second function. Then you can see that we have reached to the second line. Just integrating by parts. In the third line, we have simplified it cos n minus 1x sin m plus 1x by m plus 1 plus n minus 1 by m plus 1 into cos n minus 2x sin mx. In this third line, there is sin m plus 1x into minus sin x, that is sin to the power m plus 2x. And in the third line, we have sin mx, and we have replaced sin square x by 1 minus cos square x. Sin m plus 2x is equal to sin mx into sin square x, and we have replaced sin square x by 1 minus cos square x. In the next line, we have just simplified the line before, and at the last line, cos n minus 1x sin m plus 1x by m plus 1 plus n minus 1 by m plus 1 into im n minus 2. We have taken imn as integration sin mx cos nx dx. So simply by replacing n by n minus 2, we can get integration sin mx cos n minus 2x dx, that is im n minus 2, and minus n minus 1 by m plus 1 into imn integration cos nx sin mx dx, that is imn, and then simplifying the quotients of imn, we get imn is equal to cos n minus 1x sin m plus 1x by m plus 1 plus n minus 1 by m plus 1 into imn minus 2. This is the reduction formula for imn. Similarly, we can show that imn has another reduction formula. In the first reduction formula, we have taken sin mx cos nx, that's it, and replaced it by cos n minus 1x into sin mx cos x. So we can change it, that is by taking sin mx cos x into cos n minus 1x, no, by taking cos nx into sin mx, that is by replacing cos by sin and sin by m. So for the second formula imn, we can take sin m minus 1x into cos nx into sin x dx. That is by simply interchanging sin and cos, the places of sin and cos. Similarly, we can show that imn has another formula, that is minus cos n plus 1x sin m minus 1x by m plus n plus m minus 1 by m plus n into im minus 2n. In the first formula, we have im n minus 2. In the second formula, we have im minus 2n. You can try it yourself. There are two formulas. If you have to prove something, then you have, if you are given to prove that is imn is equal to first formula or imn is equal to second formula, then you have to prove according to that statement. But if you are given to find a reduction formula for imn, then you can simply choose it yourself and prove either first or second. Next, let in is equal to tan nx dx. Integration tan nx dx is equal to integration tan n minus 2x tan square x dx. And in the second line, we have replaced tan square x by sec square x minus 1 dx. In the third line, we have written integration tan n minus 2x sec square x dx minus tan n minus 2 x dx. Next, we have integrated it by parts. So, in tan n minus 2x sec square x dx, we have considered tan n minus 2x as the first function and sec square x as the second function, and just integrated it by parts. Next, we have simplified tan n minus 1x minus m minus 2 tan n minus 2x into tan square x plus 1 dx minus in minus 2. Tan n minus 3x sec square x tan x give us that tan n minus 2x, and sec square x is replaced by tan square x plus 1. Tan n minus 3x into tan x is equal to tan n minus 2x, and sec square x is replaced by tan square x plus 1. In the next line, we have tan n minus 1x minus n minus 2 integration tan nx dx minus n minus 2 into tan n minus 2x dx minus n minus 2. Tan n minus 2x into tan square x gives us tan nx in the second line. At the last line, we have tan n minus nx, tan n minus 1x minus n minus 2 in minus n minus 2 in minus 2 minus in minus 2. In is equal to tan n nx dx. That's why tan n integration tan n minus 2x dx is equal to in minus 2, and we have simplified the coefficients of in and have written that in is equal to tan n minus 1x by n minus 1 minus in minus 2. So this is the reduction formula for integration tan nx dx. Similarly, we can have the integration formula of integration sec n x dx, and that is sec n minus 2x tan x by n minus 1 minus n minus 2 by n minus 1 in minus 2. You can do it yourself by simply following the steps similar as integration tan nx dx, and the lines written in yellow colors, these are the reduction formula. So integration sin nx dx is equal to minus sin n minus 1x cos x plus n minus 1 in minus 2 by n. Integration cos nx dx is equal to cos n minus 1x sin x plus n minus 1 in minus 2 by n. Integration sin mx cos nx dx is equal to cos n minus 1x sin m plus 1x by m plus n minus 1 by m plus n im n minus 2. Imn, that is integration sin mx cos nx dx is equal to 1 by, okay. Integration sin mx cos nx dx is equal to imn cos n minus 1x sin m plus 1x by m plus n minus 1 by m plus n im n minus 2. And tan nx dx is equal to tan n minus 1x by n minus 1 minus in minus 2, and integration sec nx dx is equal to integration sec nx n minus 2x tan x by n minus 1 minus n minus 2 by n minus 1 in minus 2. Next, we have imn is equal to integration sin mx by cos nx dx. We will do it differently. That's why I am describing it at last. Now, if we derive the function, that is sin mx by cos nx, ddx of sin mx cos nx is equal to m sin m minus 1x by cos n minus 1x plus n sin m plus 1x by cos n plus 1x. Integrating, we get sin mx by cos nx is equal to m minus 1 n minus 1 plus n m plus 1 n plus 1. ddx of integrating ddx of sin mx by cos nx, we get sin mx by cos nx. Simply omit the derivative symbol, that is ddx, and we get the integration of left hand side, that is sin mx by cos nx. And for the right hand side, if we integrate sin m minus 1x by cos n minus 1x, then we will get im minus 1 n minus 1, and similarly we will get im plus 1 n plus 1 by integrating sin m plus 1x by cos n plus 1x, as we have considered imn as integration sin mx by cos nx dx. Next, replacing m by m minus 1 and n by n minus 1, we get sin m minus 1x by cos n minus 1x is equal to m minus 1 im minus 2 n minus 2 plus n minus 1 imn. Hence, if we simplify or just adjust the equation, we will get Imn is equal to 1 by n minus 1 sin m minus 1x by cos n minus 1x minus m minus 1 by n minus 1 im minus 2 n minus 2. This is quite different from the others, as we have first derived the function and then we have taken the integration and replace m by m minus 1 n by n minus 1 for reaching to the reduction formula, and that is Imn is equal to this. So this is very important because this is different from the others. Next, let In is equal to log x to the power m dx. Then we can just take log x to the power n as the first function and 1 as the second function. So we can integrate by parts. Integrating 1, we get x. So integration log x to the power n into 1 dx is equal to log x to the power n x minus n log x to the power n minus 1 into 1 by x dx. Integrating by parts is equal to log x to the power n into x minus n I n minus 1. So we have reached to the reduction formula of integration log x to the power n dx by simply integrating it by parts, and this is simplest reduction formula. This is simplest among all the other reduction formula because we have not to adjust or just simplify. We have to simply integrate it by parts and then we will get the reduction formula. So this is simplest. It is not given in the book. It is given in the book as just as an exercise in Shitangshu Bandyopadhyay, and the others are given, but this is in your syllabus, so I have just given it here, and this is not given in the book as worked out. This is given in the book as just an exercise. You don't have to do the other reduction formula. These are all. You have to just read it through, and these are all very easy, I think. Integral calculus is a very good part to score, but sequence and series is quite tough, I think. So have you any problem? Do you have any problem in this integrations, in this reduction formula? Then you can ask.
Ma'am, I have a question.
Okay.
Hello.
Yes. Speak.
Ma'am, if a function in an interval is integrable, so is it necessary that it has to be continuous?
Integrability? No. Integrability does not imply continuity. Continuity implies integrability, but integrability does not imply continuity.
If in that interval it is discontinuous at like countably infinite number of points, then like
countably infinite number of points.
Yes, ma'am. I'm like, we have done some problems where like we have integrated some functions which are discontinuous at some points in the interval. So we
there is a theorem called if the sets of discontinuity, if the set of discontinuities of the function is of set of measure 0, then it will be integrable. There is a theorem, I think. I know that. Measure 0. But this is...
Yes, ma'am.
Okay.
Ma'am, you complete.
So there is a theorem. I have read it in honors. That is, if the
Lebesgue integrable functions.
No, you just measure theorem is in MSc level, you know. In engineering, you don't have to read measure theory because it's a very higher theory, measure theory. That is a set of measure zero is have a definition which is very tough for engineering level. So there is a definition of set measure zero. So if a function have discontinuities, that is you are saying that countably infinite. That is countably infinite set is a set of measure zero. So if the set of discontinuities is a set of measure zero, then the function can be integrable. Then the function is integrable. Countably infinite set is a set of measure zero. So if a function has, yes, countably infinite set is a set of measure zero. That is called enumerable set. Yes, enumerable sets are the sets of measure zero. Countably finite or infinite.
Like, are we comparing the cardinality of that set, like with the when we are saying
no,
the measure
no. That is cardinality. What can I say? Cardinality.
Like natural numbers.
You can assume the cardinality. The cardinality is a term for actually for finite sets. That's not for infinite set. You can say that cardinality.
Yes,
no,
like
cardinality.
Yeah, infinite sets we can say cardinality, but we can like say like some cardinalities. Some of the infinite sets are like less infinite than the other ones. Like the size of the
size, cardinality. You know, they are not synonyms. Size is very, you know, what can I say? In a finite set, we can see the size, but not for infinite set.
Yes, we have to control bijection.
But when we can say that the set is countable, that is that has a bijection with the set of natural numbers, then we can say that it has a set of, it is a set of measure zero. And measure zero, you can't understand it now. Measure zero is quite a high level thing. It has a certain, you know, there is a measure theory. We have learned in MSc level. This is measure theory, and these are all related to analysis. Analysis is a part of topology, and topology is far more big, very much bigger theory than analysis. If you have if you can collect any book of a topology or measure theory, you can simply understand that analysis is just a part of it, a very small part of it. You know, just an example. You can call just an example. Real analysis is an example of topology, measure theory, but measure theory topology is very big theory, and there are very, you know, fundamental theories in that topology and measure theory. So you can't understand it now. Okay, you have to. Okay.
Can we use induction for these reduction formulas?
Yes. Induction. No. Induction means.
Yes, ma'am.
Induction means.
Natural number, right? Like when we are defining an n, I, and m. So
you are saying that if we can prove it for I mn for m is equal to n is equal to 1, and then we can just, you know, I k minus 1. So what can you say? No, I k minus 1, and then no, we are just
we can reduce the form to like some algebra will be required, of course, and then.
No, see, induction theory is needed when we okay, can I speak in Bengali?
Yes, ma'am.
Because I can just আচ্ছা, ইন্ডাকশন থিওরি হচ্ছে সেই সব ক্ষেত্রে মানে অ্যাপ্লিকেবল যেখানে তুমি দেখতে পাচ্ছো সিম্পলি যেটা 2 বা 3 এর জন্য হচ্ছে, হ্যাঁ, সেই জন্য তুমি একটা ফার্স্টে স্টেটমেন্ট করে দিচ্ছ, তারপর তুমি ওখান থেকে একটা কি বলছি মানে ওই
this is the induction technique, ma'am. What I'm saying is since this I and this n, when we are writing an n, it means n is a defined natural number, like some natural number. So since induction is valid on the sets which has a least number, like we have a number like natural numbers and any subset of natural number. So can't we use induction in this setup? Like
no, actually we are using we can't use induction in this because you can see that IMN has term IM minus 2 n minus 2. Okay,
yes,
and then IN has term IN minus 2 IN minus 1. So
yes,
we are not getting a formula IN.
We can use induction on m plus n. Like we can assume that for m plus n equals to t it is true, then somehow like for one if it is only IN then it is easy to do.
না আমি জাস্ট বোঝানোর চেষ্টা করছি, দেখো ইন্ডাকশন, দেখো ভালো করে ভাবো, ইন্ডাকশনে যখন আমরা কিছু একটা প্রুফ করি, যখন পিএন স্টেটমেন্টটা প্রুফ করি ওখানে কি পিএন মাইনাস 1 কিছু থাকে?
Yes ma'am.
সেটা ভাবো, কিছু থাকে ওখানে? পিএন মাইনাস 1 এর সঙ্গে পিএন এর কোনো সম্পর্ক থাকে না, কিন্তু আমরা কি প্রুফ করি? পিএন একটা স্টেটমেন্ট দেওয়া থাকে দ্যাট ইজ ট্রু ফর অল এন বিলঙ্গিং টু ন্যাচারাল নাম্বার সেট, তাই তো? একটা স্টেটমেন্ট দেওয়া থাকে যেমন হচ্ছে 1 + 2 + 3 up to n is equal to n into n plus 1 by 2, pn is equal to এইটা, তাই তো? একটা স্টেটমেন্ট, এটা প্রুফ করতে তোমাদের দেওয়া হয়, কিন্তু ওখানে কি pn এর সাথে pn - 1 এর কোনো রিলেশন আছে?
Then that তো we try to establish like
না সেটা তো করি, কিন্তু সেটা থেকে তো আবার কিসে পৌঁছই? না দাঁড়া বলছি যে ওখান থেকে কিসে পৌঁছই? pn এ পৌঁছই, তাই তো? ভালো করে ভাবো ব্যাপারটা, একটা পিএন থেকে পিএন ইজ ইকুয়াল টু পিএন মাইনাস 1 সামথিং আসি, সেখান থেকে আবার অ্যাডজাস্ট করে আমরা পিএন মাইনাস 1 কে নিয়ে নিই, হ্যাঁ, তারপর ওটা পিএন মাইনাস 1 ট্রু হয়ে যায় বলে আমরা বলতে পারি যে কোনো এন এর জন্য ট্রু হয়ে যাচ্ছে, যেহেতু এটা প্রথমে আমি ধরে নিয়েছি 1 এর জন্য ট্রু। তো সেইটা আলাদা, ওখানে পিএন এর যে স্টেটমেন্টটা থাকে ওটা কমপ্লিট একটা স্টেটমেন্ট যেখানে পিএন মাইনাস 1 এর কোনো জায়গা নেই, তাই তো? ওখানে pn - 1 থাকছে না, কিন্তু মানে একটা আরেকটার উপর ডিপেন্ডেন্ট নয়, কিন্তু সেটা বোঝার চেষ্টা করো। ওই স্টেটমেন্ট গুলো যখন দেওয়া হয় ওখানে কি pn is equal to pn - 1 সামথিং থাকে? তা তো থাকে না। কিন্তু এই রিডাকশন ফর্মুলা গুলো কি, রিডাকশন ফর্মুলাতে দেখো কোনো একটা মানে কি বলবো, একটা ইন্ডিপেন্ডেন্ট কোনো রুল কিন্তু তৈরি হয়নি, মানে আইএনটা IN - 2 এর উপর ডিপেন্ডেন্ট, IM - 1 n - 1 এর উপর ডিপেন্ডেন্ট, দেখতে পাচ্ছ তো?
ওকে ম্যাম।
তো এইটা কিন্তু ইন্ডাকশনের থেকে অনেক ছোট জায়গা। ইন্ডাকশনে তোমরা এরকম একটা ফর্মুলা প্রুফ করে তারপর আবার একটা আইএন এর জন্য আলাদা স্টেটমেন্ট বার করো, তাই তো? এটার পরও তোমাদের আরো অনেক কিছু করার থাকে, কিন্তু এখানে দেখো
IN - 1 can depend on like for induction we try to establish a relationship between IN and IN minus 1
and then we reach to a individual, that is independent statement for IN, কিন্তু এখানে কিন্তু সেটা হবে না। এখানে হচ্ছে সেটা, এখানে IN এর কোনো ইন্ডিপেন্ডেন্ট স্টেটমেন্ট পাবে না, পাবে, কিন্তু সেটা তুমি বলতে চাইছো তোমার তো দরকার নেই, তোমাকে তো রিডাকশন ফর্মুলা বার করতে বলা হয়েছে। তোমাকে তো ইন্ডাকশনের ক্ষেত্রে খালি রিডাকশন ফর্মুলাটা বারই করতে হয় না, তারপর আবার আইএন এর একটা আলাদা স্টেটমেন্ট বার করতে হয়, সেখানে IN - 1 থাকে না, তাই তো? কিন্তু এটা তো অনেক সিম্পল, এটা তো সোজা, কেননা এটা তো জাস্ট রিডাকশন ফর্মুলাটা বার করে তুমি ছেড়ে দিচ্ছ, তোমাকে আইএন এর স্টেটমেন্ট বার করতে হচ্ছে না। তো এখানে তুমি বলতে চাইছো যে হ্যাঁ আমি
ma'am, if the statement is given that this integral of sin power nx dx follows this formula, then and prove it,
হ্যাঁ তাহলে করবে, তাহলে কি করবে? IN - 2 n তো 2 নিতে পারবে না, 3 থেকে তোমাকে স্টার্ট করতে হবে, ঠিক আছে? 3 থেকে স্টার্ট করে তুমি IN এর একটা ফর্মুলায় পৌঁছতে পারবে, সেটা করতে পারবে। I1 এর জন্য আর 2 এর জন্য আলাদা করে বার করতে হবে, মানে sin x dx আর sin square x dx তো ইজিলি বেরিয়ে যাবে ইন্টিগ্রেশন করলে। তারপর 3 থেকে তোমাকে স্টার্ট করতে হবে, এখানে I3 is equal to এখানে I1 চলে আসবে IN - 2 এর জায়গায়, সেখানে I1 টা পুট করবে, এইভাবে আবার চলতে থাকবে, তখন আবার একটা স্টেটমেন্টে আসবে, সেটা আলাদা। কিন্তু রিডাকশন ফর্মুলা যেটা বলতে বোঝায় এটা জাস্ট এটা, ঠিক আছে? এটা হচ্ছে তারপর আরো স্টেপ ওই বইটার মধ্যে দেওয়া আছে, সুশীতাংশু বন্দ্যোপাধ্যায়ের যে বইটাতে, তুমি যেটা বলছো যে I3 থেকে I4 I5 করতে করতে IN এর একটা ফর্মে আসবে, কিন্তু সেটা তোমাদের মানে ওটা পড়ার জন্য, ফর্মুলা কিন্তু এটা, বুঝেছো তো ব্যাপারটা? ইন্ডাকশনে এই রিডাকশন ফর্মুলাটা লাগে, তুমি যেটা বলছো সেটা ঠিক, বুঝেছো? এটা কিন্তু অনেক কম পরিশ্রমের, ওটা অনেক টাফ, ইন্ডাকশন অনেক বড় ব্যাপার, আর এটা হচ্ছে জাস্ট একটা রিডাকশন ফর্মুলা বার করে তুমি ছেড়ে দিবে, আর কিছু তোমাকে করতে হবে না। এরপর আর তোমাকে কিছু দেখাতে হবে না, দেখাতে যদি বলে তবে দেখাবে, নয়তো দেখানোর কোনো দরকার নেই। ঠিক আছে, আর কারোর কোনো কোশ্চেন আছে? Does anyone have any question? আর কারো কোশ্চেন থাকলে বলো, আমি আর আজকে পড়াবো না, আমি নেক্সট ক্লাস থেকে সিকোয়েন্স শুরু করব। আচ্ছা, একটা জিনিস আমি জানতে চাই যে তোমরা মেজরিটি মানে কি কিসে কথা বলো, বাংলা, হিন্দি না ইংলিশ, সেটা আমাকে বলো একটু। মানে বেশিরভাগ কি ভাষায় কথা বলো?
Ma'am, it depends on against whom we are speaking. And with whom
Yes,
we will
I know
speak
that.
against.
So
Generally,
বাংলা।
আচ্ছা, কিন্তু আউটসাইড ওয়েস্ট বেঙ্গলের অনেকজন আছে, তাই তো? There are many students from outside of West Bengal. I have seen it in
Yes,
the
ma'am.
roll sheet. Okay. So, will I continue speaking in English? Or
yes, ma'am.
okay, that will be better. No, acha. Speaking in English will be helpful for you. Actually, I can speak English quite well, but I am comfortable in Bengali because I speak in Bengali in my home all time, and that's why I have not that good practice in speaking English for quite some time, and because the university is closed and we are not taking offline classes, that's why the practice is totally gone, and I am just, what can I say? Because okay, and I want to clear a thing. In the first sem, there are some students from IT and print who were just starting musics and videos in between the classes, and that was very annoying. So I just simply hope that you are much decent and I don't have to face that problem again in this sem. And I know you are all very good students, but still I am just clearing that thing. তোমরা নিশ্চয়ই জানো, ঠিক আছে?
Ma'am, till now we have not done this, and in the future also we will not do this.
হ্যাঁ,
You
আমি
can be
দেখো, আমি
assured.
কিন্তু বলছি না যে তোমাদের মধ্যে কেউ করবে বা কিছু, আমি বুঝতে পারছো তো, মানে সেটা দেখা তোমাদের দায়িত্ব যে কোনো ট্রেস পাসার এসে যাতে ওটা না করে, সেটার জন্যই আমি তোমাদের বলছি। আমি জানি তোমরা কেউ করবে না, ঠিক আছে? কখনো ভেবো না যে ম্যাম তোমাদের উপর ডাউট করছে। I have no doubt in you, but still I just want to clear that thing because that is very annoying. আর লাস্ট টাইমে কি হয়েছিল জানো তো, একজন স্যার মানে রীতিমতো বিরক্ত হয়ে একটা ক্লাসের পর আর ক্লাস নেননি ইংলিশ ক্লাসে, ঠিক আছে? তো আমার ক্ষেত্রে হয়েছিল, আমি তো তাও অনেক জুনিয়র, বাট আমার স্যারের ক্ষেত্রে হয়েছিল, মানে অরিন্দম স্যারের ক্ষেত্রেও কিন্তু লাস্ট টাইমে এই কাজটা করেছিল। কে করেছিল জানি না, ওরা বলছিল ওদের রেগুলার স্টুডেন্টদের মধ্যে নয়, বাইরে থেকে কেউ এসে করেছে, কিন্তু সেটা দেখা আফটার অল তোমাদের দায়িত্ব। আর সেই জন্য এবার আর মিটিং লিঙ্ক আমরা তৈরি করছি না, তোমরা মিটিং লিঙ্ক করবে, তোমরা দেখে শুনে জাস্ট অ্যাডমিট করো, ঠিক আছে? সেই জন্য যখন অ্যাডমিট করবে, যে অ্যাডমিট করছো সে দেখে শুনে প্লিজ অ্যাডমিট করো, যাতে কোনো ট্রেস পাসার এসে উল্টো পাল্টা যাতে না করে, ঠিক আছে? জয়দীপকে আমি বলছি, জয়দীপ আমাকে মিটিং লিঙ্কটা পাঠিয়েছিল, ঠিক আছে? তো আমি সেটাই ওকে বলতে চাইবো। আছো জয়দীপ?
হ্যাঁ ম্যাম, আছি।
হ্যাঁ হ্যাঁ, তো জয়দীপকে আমি বলছি যে যখন অ্যাডমিট করবে ঠিকঠাক ভাবে দেখে করবে, ঠিক আছে? যাতে ভুলভাল কেউ না ঢুকে পড়ে, কেননা সেটা খুব খারাপ হয়, ঠিক আছে? গতবার জানি না কেউ কমপ্লেন করেছিল কিনা, তো কমপ্লেন করলে কি হবে বলো তো, তোমরা কেউ করছো না ঠিক আছে, কিন্তু তোমাদেরই প্রবলেম হয়ে যাবে। যদি কেউ বাই চান্স একটা মেলে কমপ্লেন করে দেয়, তাহলে কি হবে, তোমাদের পুরো সেমিস্টারের জন্যই ক্লাস বন্ধ হয়ে যাবে। কেউ আগের বছর কমপ্লেন করেনি সৌভাগ্যবশত, এখানকার স্যাররা অতটা কেউ মানে টাফ নয়, আমিও করিনি কমপ্লেন, কিন্তু খুব খারাপ ব্যাপার, আমার দুটো ক্লাসে এরকম হয়েছিল আর খুবই খারাপ ভাবে হয়েছিল ব্যাপারটা। তো সেটা আমি চাই না হোক, তো এইবার তোমরা বি কেয়ারফুল, সেটা যাতে না হয়, ঠিক আছে?
Ma'am, please can you send the PDF in the WhatsApp group?
No, I will send it after finishing all my classes in the end. Okay.
Okay, ma'am.
And I have not created PDF. I have just created this PowerPoint presentation. Okay, I will send it after all my classes are over. But that doesn't mean that you can't don't have to attend my class. You have to attend my class. Okay. Otherwise, I will not share it. If I see that the majority is not is not attending my class, then I will not share my presentation. Okay,
ma'am, but one problem is there, ma'am. Ma'am, in this current situation where everyone is not having the books or can't buy the books, in this lockdown situation, so it will be easier for us to if we get the PDF.
Okay, তোমরা যদি বই না পাও, ঠিক আছে, আফটার শেষ পর্যন্ত যদি তোমাদের বই না হয়, তোমাদের ইন্টিগ্রাল ক্যালকুলাসের জন্য বই আমি যা দিয়েছি সেটাই যথেষ্ট, তার বেশি লাগবে না। ইন্টিগ্রাল ক্যালকুলাসের জন্য তোমাদের বই আমার পার্টের জন্য কালেক্ট করতে হবে না। কিন্তু যদি লাস্ট অব্দি তোমরা বই না পাও, আমি তাহলে আমার বই থেকে ছবি তুলে তোমাদের পাঠিয়ে দেবো, ঠিক আছে? আমার এসকে মাপার যে বইটা আছে সেখান থেকে ছবি তুলে তোমাদের পাঠিয়ে দেবো, তোমরা আমাকে বলবে। Then I will share the screenshot, share the JPEGs from my book and send it to you. Okay, you don't have to worry. Okay,
ম্যাম, আমি বলছিলাম কি আমার এরিয়াতে একটু নেটে প্রবলেম হয়, তো আমি তাই বলছিলাম।
নেটের প্রবলেম হয়? হ্যাঁ, ঠিক আছে, আমি তো
হ্যাঁ ম্যাম বলুন।
শেয়ার করলে তো পেয়ে যাবে নাকি? মানে সেটা তো পেয়ে যাবে, একটা না একটা সময় তো ডাউনলোড হয়ে যাবে যদি শেয়ার করে দিত, তাই না? হ্যাঁ, তো সুতরাং সেটা
ক্লাসের ব্যাপারে আমি বলছিলাম কি কখন কখন আমার হয়ে যায়, আমি লিভ হয়ে যাই, তো এই জন্য আমার মানে কি বলবো, অনেকবার আমি লিভ হয়ে যাই, এই জন্য অ্যাটেন্ডেন্সে কিছু হবে না তো ম্যাম, এই জন্য বললাম। আমি জয়েন করি, অনেকবার লিভ হয়ে যায়, তারপরে আবার মানে জয়েন করার চেষ্টা করি।
না, ওটা কিছু হবে না, অ্যাটেন্ডেন্স আমি ওই জন্য শেষেই নিই, ঠিক আছে? আমি অ্যাটেন্ডেন্স প্রথমে নিই না। তো সুতরাং ওইটা নিয়ে কোনো প্রবলেম নেই। আর অত তোমাদের চিন্তা করতে হবে না, তোমরা ইঞ্জিনিয়ারিংটা নিয়ে ভালো চিন্তা করো, ভালো ইঞ্জিনিয়ার হও, যাতে বাত ফাত না ভেঙে যায় পরবর্তীকালে, সাইবার সিকিউরিটি ইন্টারাপ্টেড না হয়। হ্যাঁ, সেটাই, এখন তো অনেক ইঞ্জিনিয়ারের দরকার আমাদের দেশে। সাইবার সিকিউরিটি মানে কি বলবো, খারাপ হয়ে যাচ্ছে, হ্যাকড হয়ে যাচ্ছে, এটিএম থেকে টাকা চুরি হচ্ছে, অনেক কিছুই হচ্ছে দিনকে দিন। তো আমি চাই ভালো তোমরা ইঞ্জিনিয়ার হও, ব্যাস, আর কিছু চাই না, ঠিক আছে? নাও, এবার স্যার তো এসে গেছেন, তাহলে স্যার কন্টিনিউ করুক, ঠিক আছে স্যার?
ওকে ওকে ওকে, হ্যাঁ ঠিক আছে, থ্যাংক ইউ।
ওকে স্যার, ওকে স্যার।
ওকে, সো I'll now present the screen. Now, can you see the blank page?
Yes, sir.
Everyone?
Yes, sir.
Okay. So, in this section, I will deal with improper integration. Improper integration. Now you know that integration, what you have learned up to your 12 and just in the previous class also, that are proper integration. Proper integration means that you have I have a to b fx dx. This is your integration, a definite integration. And here this function may be undefined at A, or may be undefined at B, or may be undefined within this A or B, or maybe some A or B may be infinite. So in that cases, they are not proper integration. For the proper integration, there will be no discontinuity between the intervals. These are the intervals, you know. You have seen the fundamental theorem of integral calculus, which is for the proper integration. Fundamental theorem of integral calculus, what you have learned in your class 12 also. That is for the proper integration. That means the function is very much well defined between these two intervals, A and B. And there is no discontinuity within this interval. The interval is given on the, this is the closed interval AB. So there is no discontinuity between these intervals, or these B and A are not infinite. So we will deal with now this improper integration, where the function will be discontinuous within this interval, or the limits will be infinite. So there are two types of improper integrations, two types. Two types of improper integration are there. So first type is like this one, minus infinity to A type of thing, minus infinity to fx dx. Second one is this one. And the third one is the combination of these A and B, this one. So this is type 1 of improper integration, where there are infinite, the integral is between the infinite one. It is minus infinity to A.
Sir, the screen has stopped.
This is A to infinity, and this is minus infinity. Pardon?
The screen has freezed actually.
You can see it, na?
Sir, there is no movement.
You can see the.
So now it's visible. Actually, in the middle of the you are writing, the screen freezed. That's why we are not seeing anything.
Okay. Actually, some internet connection problem is maybe there. The internet connection is very low.
So it seems that your device is too far away from your laptop or computer, sir, as the tower is very low.
Okay, now you can see this thing. Okay. Now, how to evaluate this thing? Our main thing is that how to evaluate these things. So first one, for the first case, we can take this limit A tends to minus infinity, A to A fx dx. We evaluate. We evaluate this one. A limit A tends to minus infinity, A to A fx dx. And if the limit exists, if the limit is, that means if you can find the value of this limit, then that will be the value of the integration. So we will find the limit of this one. Limit a tends to minus infinity to a fx dx. And after integration, first you have to do the integration as usual. What you have to do the how you do the integration. First you do the integration and then you find the limit a tends to minus infinity. If it gives some value, if it gives some value, say 0 or 1 or pi by 2 or like that, then we will say that this integration has the value that one. Okay, I'm coming to examples afterwards. First I complete the theoretical part, the main thing. Second one, same thing. We find, we evaluate limit b tends to infinity a to b fx dx. And again, if this value exists, if you get the value, then this is the value of this improper integration. Okay. And for the third one, for the minus infinity to infinity fx dx case, you have to break in two because there is a 0 in between minus infinity to infinity. So first you write this one as minus infinity to 0 fx dx plus 0 to infinity fx dx. And that can be obtained by this one, limit a tends to minus infinity a to 0 fx dx plus limit b tends to infinity 0 to b fx dx. So this is the first type of improper integration, where you can find the improper integration in this way. By evaluating the limit, you can get the, if this limit does not exist, that means if this limit is infinite or something, then this integration does not exist. So improper integration always may not exist. If the limiting value is finite, you can find any limit of that this integration. After integration, if you find the limit and if the limit exists, then only this improper integration exists and you can get the value of that. For example, now I'll give an example of that. Say example, suppose I gave minus infinity to 0 dx by 1 plus x square, this type. So this is improper integration of first type, and here it is minus infinity to 0. So to evaluate it, how to evaluate? So we consider limit a tends to minus infinity a to 0 dx by 1 plus x square. So that is limit a tends to minus infinity. Now what is the integration of dx by 1 plus x square?
Tan inverse x.
Yes. Tan inverse x a to 0. So it is limit A tends to minus infinity. So tan inverse 0 minus tan inverse A. Okay. So that means what is the value of this? Limit A tends to minus infinity. What is tan inverse 0? 0 minus tan inverse, and it is minus pi by 2. What? It is tan inverse A. I am writing first this one as this one. So that means it is minus pi by 2. So it becomes pi by 2. So this value exists. This improper integration exists, and the value is pi by 2. Okay. So in this way, you can find any this type of problem. We'll do more example the next day. I'll just I'm showing the type. So this is same problem may be given as 0 to infinity dx by 1 plus x square, or it may be given by minus infinity to infinity dx by 1 plus x square. You can find it. You can find these values. Okay. Now this is the type 1. So we have discussed about the type 1 of improper integration. Now let us see the type 2 of improper integration. Now this is very important. Type 2 is we have a to b fx dx. This one, this looks like it is very we can do this integration, but the function may be undefined with this, where fx may be undefined. Within this interval. So what we'll do in that case? First one, or I can do as A. Okay. Yes, ABC we have done. So here also we'll do as ABC. Here the first one, that fx is undefined at x equal to a. Fx is undefined at x equal to a. That means it is this limit at x equal to a. First case, fx is undefined at x equal to a. Then what we'll do? We find this way. So let epsilon tends to 0, and we find this limit epsilon tends to 0, a plus epsilon b fx dx. So this is the value of when fx is undefined at x equal to a. It is undefined at x equal to a. So we find the value of this one, limit epsilon tends to 0, a plus epsilon b fx dx. And if this limit exists, if we find any value, if limit exists, after integration taking epsilon tends to 0, if we find the value of this limit, if limit exists, then this improper integration exists, and the value is the limiting value. Okay. Second case, Second case, if fx is undefined at x equal to b, in that case we find limit epsilon tends to 0 Can you see or
Yes, sir.
Yes, sir.
No, actually I'm checking the internet is very low, showing very low connection. That's why. So now here it will be a b minus epsilon. It is a because as it is from the interval a to b, so in the left hand side of a it is not within this interval, so that's why you have taken here a plus epsilon, and again here it is b minus epsilon. That means we are inside the interval now. So this one, if epsilon are undefined at x equal to b, in that case we find limit epsilon tends to 0 a b minus epsilon fx dx, and again if the limit exists, then the value will be this one. Now for this third one is very important. Third one, if fx is undefined, within the interval AB. So in that case, we find fx is undefined within the interval AB. So in that case, we find suppose it is undefined at x equal to c, where a less than c less than b, then
sir, this can be less than equal to, na sir?
No, because equal to case of first 1 and 2 we have considered, so we are not taking
yes sir, okay sir.
So it is within the interval. Okay. Then we find, but see, limit epsilon 1 tends to 0. A c minus epsilon 1 fx dx plus limit epsilon 2 tends to 0 c plus epsilon 2 b fx dx. So we find these two limits and add this one. So this, if this value exists, if this limit exists, then only the improper integration exists, and the value is the limiting value, and the value is the limiting value. Now this is a very important one, because sometimes it happens that suppose this one may exist, this limit does not exist, or if you add this one, epsilon 1 and epsilon 2, they are different limits. So sometimes this does not exist. After getting this limit and after getting this limit, if you add, it may be infinite or something like that. But if, note, if epsilon 1 equal to epsilon 2 equal to epsilon, if for epsilon 1 equal to epsilon 2 equal to epsilon, the value, the limiting value exists, then we say that the improper integration has a Cauchy value. It is called a Cauchy value if for different epsilon, epsilon 1 and epsilon 2, it may not exist. This limit does not exist. But if you take epsilon 1 equal to epsilon 2 equal to epsilon, if you take these two epsilons equal, then sometimes this value may exist, and that value is called Cauchy value of the improper integration. Cauchy value, because it's given by Cauchy, you know, the mathematician. So this value is called Cauchy value of the improper integration. So these are the three subsections of the second type of improper integration. So let us give an example. So let us give an example of these things.
Excuse me, sir.
Yeah.
Sir, if let's say it is the limit does not, if it is not continuous within the function and at the end, so will we add the cases B and C like that?
Oh, for both the cases A and B, it is not defined.
No, sir. Let's say it is not defined at B and it is not defined somewhere in between. Sir, if both of, so will we add cases like that? If can we add cases B and C like that?
You are talking about that it is undefined at the B and in between.
Yes, sir.
In between. Yes, then you have to first you have to take this one for the between case, then you have to take also this case also. So both B and C we have to consider.
Okay, sir. Okay, sir.
Now see, for example, if I consider this example, sometimes we take this integration very dx by x cube, suppose this one, minus 1 to 1 dx by x cube, this improper integration. Now see, if in your class 11, 12, you just find the integration without knowing that it is improper integration, because you find the integration of x 1 by x cube and you take the limit and you get the value, but that is wrong, because this is an improper integration, because fx is undefined. Fx is undefined at x equal to 0 in minus 1, 1. So you can't find the integration directly because it is not a proper integration. So to find it, we take this value. We take limit epsilon 1 tends to 0, x equal to 0, so it is minus 1, so 0 minus epsilon 1 dx by x cube plus limit epsilon 2 tends to 0. I'm considering the third case, so that same for the previous cases A and B. So this is limit epsilon tends to 0. We can take 0 plus epsilon 2 1 dx by x cube. Now you find the values. How much is coming? I will not do the integration. You do the integration and take the limit. Just you tell me the steps. Limit epsilon 1 tends to 0. So I'm writing just this one. Limit epsilon 1 tends to 0. Now what I will write here, plus limit epsilon 2 tends to 0, and what I will write here. So tell anyone. Just very easy.
1 upon.
Yes. 1 upon
minus 2x square.
1 upon minus 2 x square.
Yes.
So now it is minus 1 to minus epsilon 1 here.
Is a minus 3
it is
plus
also
1.
minus 1 up. It is epsilon 2 to 1. Is it okay?
Yes, sir.
And then you find it, you take the limit. So you find the limit. It will be when you put the minus epsilon here, it will be minus 1 by 2 epsilon 1 square, and then it will be
minus 2 epsilon 1.
Huh? 1 by 2.
Minus 2 epsilon 1 in the denominator.
No, I am putting here minus epsilon. Minus epsilon, so it is minus 1 by 2 epsilon, and minus minus of minus this one, and it will be 1 square. So is it right? Is it right?
Yes, it is. Yes, it is.
Plus again limit epsilon 2 tends to 0. It is again for 1, it is minus half, and minus plus again 1 by 2 epsilon 2 square. Like this. It becomes like this. So now you see that so whenever epsilon tends to 0 and epsilon 2 tends to 0, the limit does not exist. The limit does not exist because it is infinite. Epsilon tends to 0 means infinite. Infinite plus something means infinite. This is also infinite. So that means it is infinite actually. It is infinite. So whenever epsilon tends to 0 and epsilon tends to 0, the limit does not exist. But if we consider epsilon equal to epsilon 2 equal to epsilon, then what happens? Epsilon then minus 1 by 2 epsilon square plus half minus half plus 1 by 2 epsilon square. So this will cancel out and this will cancel out. So it becomes 0. So the Cauchy value, so the improper integration So the above improper integration. So the above improper integration does not exist in general, but its Cauchy value exists, and which is equal to 0. So actually this improper integration does not exist, but its Cauchy value exists, and the value is 0. Improper integration, the value of this improper integration.
Sir, what is the significance of Cauchy value? Means, sir, what is
no, actually, in general, this improper integration does not exist, but sometimes this may be applicable in various consideration, in that when these two are equal, then the value is coming, you are getting a value. That is important. So in some, suppose in some mechanical problem, or some differential equation, for the solution you may not get the value for different limits. So when you take the limits equal, that means if you approximate very much, then you are getting a value. So that will help you to calculate something. That is the importance of this Cauchy value. Okay. In general, it does not exist, but when
Sir, in the second case too, sir, the individual limits are not existing, right, sir? So the addition of the limits are existing. So can we ignore the individual limits not existing?
No, you can't ignore, because this one. No, what you want to say?
So the individual limits does not exist, sir. The addition of the limits exists. So that's what I was asking.
No, yeah. Actually, in when this epsilon and epsilon are different, then their addition is also does not exist. And individually it does not exist.
Sir, when they are same, that's when I was asking. Sir, if they're same, then also the individual limits are not existing, na?
No. Yeah. So in that case, it is not defined. So,
but the addition is existing.
Yes. Addition is existing. So in that case, individual, if you consider the individual case, then it is improper integration will not exist.
Okay, sir.
Okay. So this is the our two types of improper integrations. The first one is infinite limits, and the second one is the type 2, when there will be the undefinedness within the interval. So these type of two improper integrations are its application. Its application is beta gamma function. Application is beta gamma function. Application is beta and gamma function, because the gamma function is the type 1. Gamma function is type 1 improper integration. Type 1 improper integration is the gamma function. Why? Because it is defined as in this way. This one. So the limit is infinite. So e to the power minus x, x to the power n minus 1 dx. This is known as gamma function.
Sir, what is the notation here?
This one?
Yes, sir.
It is called gamma. It is called gamma, capital gamma. You know alpha, beta, gamma, alpha, beta, gamma, delta. Okay. So this is small gamma and this is capital gamma.
Inverted L.
Yes, like this. No, this one. This one.
Inverted
and this one is gamma n. Inverted L. Yeah. Inverted L like that. So it is capital. It is capital one. Capital gamma.
So it is gamma of n or gamma of x?
Gamma of n. Gamma of n. Okay. So this is important. This value is important. The power.
Sir, what is the upper limit, sir? Alpha?
Infinite.
Okay.
0 to infinity.
Okay, sir.
0 to infinity. And this gamma n, gamma n plus 1 equals to n gamma n, property 1. Property 1 is gamma n plus 1 equal to n gamma n. N gamma n. So, and if n is positive integer, then gamma n plus 1 equal to factorial n. You can prove this one, though the proof is not so important, but you can find it because gamma n plus 1 equal to 0 to infinity e to the power minus x, x to the power n dx, x to the power n dx. Now it's the same way, limit a tends to infinity, 0 to a, e to the power minus x, x to the power n dx. Now, how will you find this value?
Sir, Eilert theorem?
Yes, you take the product of two functions and use Eilert theorem and you find the value. You will get that it is n gamma n. Okay, so you will find n because you can't evaluate it because there is a is infinite. You can't evaluate it, but you will get n gamma n. Okay, just you find the limit this value. Find it just by using product integration of the product function. And if it is n is positive integer, and if n is positive integer, then gamma n plus 1 is factorial n because n first it is n gamma n, then n minus 1, gamma n minus 1, then n minus 1, n minus 2, like this. It will come to. So gamma n plus 1 will be like n minus 1, n minus 2, likewise. It will come e to the power minus x, integration of e to the power minus x, and if you integrate it, it will come 1. So gamma n plus 1 you will getting. So this is important. These results are important. We have to remember that if n is positive integer, then gamma n plus 1 is factorial n. But in general, gamma n plus 1 is n gamma n. When n is not a positive integer, it may be fraction also. It may be fraction. So these are two, just property 1. This is property 1.
Sir, what if n is a negative integer?
No, for negative integer it is not defined. Okay. It is, yes, good question, but it is for negative integer, it is not defined. It is for positive integer or fraction. For n greater than 0. Yes. For here, we should mention here n greater than equal to 0. For 0 for n greater than 0, and for 0 it is for n greater than 0 there is. For n equal to 0 it is not defined. Gamma 0 is not defined because gamma 0 n equal to 0 you can't take the integration properly because it is coming to x e to the power minus x by x dx. Okay, and I think we can't find the value of that one. So it is for n greater than 0. And there is more properties are there. Gamma. Okay, the next day we shall proceed further. I'll just give the beta functions definition. Next day we'll do some problems and more properties. So what is beta functions? Beta mn. Beta mn is defined as 0 to 1 x to the power m minus 1, 1 minus x to the power n minus 1 dx. This one. This is called beta function. 0 to 1 x to the power m minus 1, 1 minus x to the power n minus 1 dx. Now see for mn less than 0, here mn mn not less than 0, it is between 0 and 1. For between m and n 0 and 1 it is improper integration, but for mn greater than 1 it is a proper integration. Okay, for 0, this one, for this one it is improper integration because when it is less than 1, suppose it is half, say for beta half, for beta half, what you are getting? 0 to 1 x to the power minus half and 1 minus x to the power minus half dx. That means, so these are coming to 0 to 1 dx by root x and root 1 minus x. This one. So it is for x equal to 0 it is undefined, and for x equal to 1 it is undefined. So it is improper integration. So improper integration. It is improper integration for mn lying between 0 and 1. But mn for greater than 1, for mn greater than 1 it is always it is a proper integration, and you have done this type of problem. X squared 1 minus x cube or x to the power 5 1 minus x to the power 4 dx, like that. So you can do that type of integration. But
sir,
this
what if m greater than 1 and mn and n lies between 0 and 1?
Then also for one case it is improper, no? Okay. For one case it is improper. So it is improper. Okay.
Yes, sir.
Because actually the 0 and 1, either it will be undefined for 0 or for undefined for 1 or within this interval. So in that case it is improper integration. Otherwise it is proper. So if one value is, suppose it is less than 1, so in that case it is root x, and for this one is it is will be upper, so in that case it is undefined and it is beta it will be improper integration. So this is the definition of beta function. And
sir,
there
Sir, we can't hear any.